at bonding in metals and something about metal structure. Over the past few sessions we've looked at previous videos. You can look at ionic bonding, and you can look at metallic, and you look at covalent bonding. Today we're going to look at metallic bonding. So let's get in and have a look at what we're going to do. So we've met already bonds where we have metals bonded to non-metals. This is ionic bonding. We've met non-metals bonding to non-metals. This is covalent bonding, and this is bonding a metal to a metal, and we'll call this metallic bonding. Now, what does it look like? Well, basically, if we think about a metal as a series of atoms here, they form up in layers, and I'll just draw just a few atoms for you. Each of these is positively charged. It's lost, each one's lost one or more electrons, and these are then what we call free electrons that move around. So they're free here to move around the metal. So these free electrons are basically not bound to any of these particular atoms, and we'll call them delocalized. So these are delocalized electrons, and the metal forms basically flat sheets. Okay, how does this give us some idea about how the bonds work? Well, since we've got positively charged metal ions surrounded by, if you like, this sea of delocalized electrons, there is a strong bond here, and this attracts and keeps all the atoms in place. And very strong this is too, as seen by most metals. They have generally a high melting point and a very high boiling point. There are, of course, a few exceptions to this. We've got mercury being one, and gallium being another. Gallium's quite a nice, interesting metal in that we can get this to melt in our hand. Gallium, if I just grab some, for you to look at. Here is some gallium, and here it's solidified. It's above, its melting point is around about 29-30 degrees centigrade, so this is a solid. But if I warm this slightly, then we can have a look at some of its liquid properties. And what I'm going to do with this in a minute is I'm going to heat this up very, very gently so we can see what it's like. At the moment I can't do anything to this. It's sort of really solidly sort of welded to this Petri dish. So that's gallium. We will have a look a little bit at, yes, wet. Have a look at mercury, but we'll see what we can do about this later. Right, so what does a metal look like and how does it work? Well, there's a few experiments that we can actually do to have a look at this, and what we're going to do is have a look at in a moment some crystals of metals, and so we can have a look and see what they look like. So we've got quite a few interesting metals that we can look at, and we've got a setup so that we can look at under the microscope. We've got some simple metals that we can have a look at and examine what they are like. We'll come back to those, but what I want to do is I want to have a look at a metal still, and here we've got some organ pipes, and what we might be able to do with these organ pipes is zoom in, and what I'm going to get my son to do is take another picture of this closer up, which is what I thought he'd done. But if we look carefully at these organ pipes, you can see that we do have a sort of a mottled effect, and what Paul's going to try and do for us in a minute is what I thought he'd done, which was to zoom in on the crystals so we can actually see what they actually look like. But more of that in a moment. So I'm just gonna...
Sorry, I'm not sure.
And Alexa's not helping either. Right, okay. Paul's going to look at some of those crystals, try and zoom in a little bit so we can have a look at the crystals. And what we're also going to look at is how we might make some metal crystals. So let's go over to the lab and see what we can do. One of the experiments that we can try is using silver nitrate, and we're going to put that in a test tube and have a look at how we grow some crystals. So for my setup, I've got a clean test tube, and we've got some copper wire. This copper wire, what I'm going to do with it is I'm going to wind it around a pencil. Takes a few moments to do this. But as you can see, I'm making a sort of a coil. We'll take that off the pencil, and now you can see this. If I zoom in a little bit, there I've got my coil of wire. Right, we'll zoom back out so you can see what's going on. This coil of wire I'm then going to place in the test tube. We can bend this over and typically cut that off, and what we can do is we can pour in some silver nitrate into the test tube, and then we're going to leave that for a little while. Now I've actually done that a little while ago, and I'm storing that in the dark, and I'll have a look at that in a few minutes. So we're going to leave that experiment to go for a few minutes, and then when we've done that, what I've got is a microscope that we can go and have a look at. So this has got my camera on top of the microscope. We've attached the camera to the microscope on low power, and I've got a small light here, and then if I put the microscope on, there we've got a coin that we can use to have a look under the microscope at. And you can see as I move it around, we've got this coin. This is just a 2p piece under the microscope. Looking like a 2p piece, I suppose. And I've set it here so that we've got an edge, and this is about 40 times magnification. And if we have a look at this setup, then you can see what we've got to try and have a look at this 2p piece. So I'm just resting it on there. Now what we're going to try and do is we're going to try and have a look at this with these silver crystals, because what we're going to try and do is, I'm just going to switch this off and move it out of the way. What we're going to do then is, by having my copper in here and the silver nitrate, the silver crystals are going to form on the copper, and we're going to get a small amount of crystals that we might hopefully see under the microscope. And what we do is we set this up and we leave it for half an hour to an hour or even more to get some really good crystals. So let's just do this. There's my wire. Let's pour in some silver nitrate. And now what we need to do is leave this in the dark for a little while to see what happens. But what you may see immediately is something happening. The copper colour is changing as we're getting some crystals forming on here. Now I need to put this in the dark because it grows better in the dark, so Paul's just going to move the camera back, and we're using an ingenious place to store it in the dark, so we're just going to put it in the dishwasher. And Paul might show you that. So in the dishwasher here we've got some crystals that I have already been growing for a few minutes. And what I'm going to do is I'm just going to leave that in there just for a few minutes and see what we get. Oh look, this is the one I prepared earlier. Bring it in close and you can see that we've got quite a few crystals formed here. It's looking a little bit horrible. So what we're going to do is we're going to get this out of here, and we're going to see if we can see them under the microscope. I've got a bit of tissue to put this down on. I'm just going to try and gently lay this down. Paul missed that little bit. I'm going to just try and gently lay this down. On a piece of paper so we can get something. And in fact, I might be able to see a few little crystals forming. Right, now, let's have a look at this under the microscope. So let's switch the camera on. I'm going to put the light on. And very carefully I'm going to lay some of these crystals on there. And then what we're going to need to do is try and focus this. Right, let's start focusing again. There we can see some crystals of silver having formed. Now this is about 40 times magnification, and what I'm going to get Paul to do is just to sort of move the focus around a little bit using the big knob. And it's too much. There we are. And we can see as we move along the wire, we can see these little crystals forming. And I think we'll go back to where we were. And then we can see probably better some crystals on this little coil of wire. Not so easy to look at because it's basically a coil, and a coil doesn't sort of fit in the microscope terribly well. But we're trying to sort of get some crystals that we can see fairly easily. I'll try some just at the end here. And let's focus again on this. Trying to put it in the centre so I can see this reasonably well. And we can see perhaps some very tiny little crystals of silver there. It's very hard to focus this, especially when I'm standing so far away from the system. So we've got some crystals here of metal that we can sort of look at. Okay, from the microscope back to the other view. There they are, all formed on here. Paul's just going to focus a bit better. And fairly yucky they look, but we do have some small crystals. Okay? Right, if we zoom out, and I'm just going to move the microscope and its camera out the way. then we've managed some crystals, and it takes about half an hour to an hour or so to try and make some crystals. And if we look at our silver solution, the silver solution is now going a bluish colour. Like you can see that better if we hold up a piece of paper behind it. And there's a bluish tinge because this is forming from silver nitrate copper nitrate. And what I'm hoping to do is just push that back in again, and we can leave that to see what happens a little bit longer. And to do that, I'm going to put it back in the dark in the dishwasher, and there it can stay safely. Right, now our next job is to have a look at what the metals really look like. And so let's get some sort of idea what it looks like. And to do this, I'm going to make a metal simulator. And Paul's just going to zoom in for me. And we've got a petri dish here. The petri dish is got some water in it here, and the water's got some washing up liquid. And if I can blow very gently, we'll see if we can make a metallic structure. Well, very badly I've done that. This is our selection of crystals. I can burst a few of the bigger ones, and they should, if I manage to blow them nicely, all be approximately the same size. But they're not usually. But this is what a metal looks like. Now, with the metals, sometimes we can get them sort of moving around here. You can see the metal can move around. But what I've got is some bigger bubbles. And if I've got some bigger bubbles, these prevent the movement around. And that's what we get when we get an alloy. Try this once more. Still keep ending up with one big one. But over this side I've got some reasonable structure of the metal. All these tiny little bubbles joined together. And if we get some bigger ones in there, then this causes this metal to have a structure so that it can't bend and move as easily, and that we call an alloy. Now hopefully Paul's done a picture of this for me, and he's looking at me. And here is our pipe that we looked at earlier, and he's done a good job now. Well done, Paul. And we can see the crystals, and if you look carefully you can see that we've got big crystals here on the pipe of lead and tin, and it's these shapes that sort of make an interesting sort of tonal quality to the organ pipes. And the skill of an organ maker is trying to get this right mixture. So here we got lead and tin forming an organ pipe, and you can see that after a few years, and these pipes are now probably about 100 years old, they have formed rather nice large crystals, and this does something to the tonal quality. I play an organ, I don't have to understand why they seem to make better noises just because of their crystalline structure, even though I'm a chemist. There we are, a good view of a pipe. Okay. So we've done one experiment where we've mixed copper and some silver nitrate, and we've got some crystals. Now they don't look brilliant, and when we look at them carefully sometimes we can see them better under a microscope. The crystals look to sort of a funny sort of yucky sort of greeny colour to me, rather than beautiful colours of silver. Now why that is due to all the copper that's present. We've then looked at some different metals, such as tin and lead there in a pipe, and we seem to blow our shape into a petri dish and see what the bubbles look like. Now what I want to do is I want to have a look at, just seen how things are ready, some metal crystals. Let's go and have a look. Let's put this one out of the way, and let's see what we've got. I'm just putting down a little crystal here that Paul's going to have a look at, and this is the metal bismuth. Now this piece of bismuth, as far as I know, is formed by a whole series of crystals, and you can see that these are really quite a pretty colour. They're not one particular colour, but we've got a whole series of different colours in here, and that is an artifact of the light, that as the light falls on this in different places, so we're getting a slightly different colour tinge. And as I rotate this, you might see this happening. Right, this is bismuth. You've probably seen other metals. This bismuth could have formed, and I'm not saying this one did, this one could have formed in something like this. This is a geode. This is a boring rock, and that's what it looks like on the outside, but if we smash this with a hammer, inside we can find rather pretty little crystals, and in some of those we might find things like bismuth growing, because these take a long time to cool down, and as they take a long time to cool down, then what they do is they form these beautiful crystals. Right, looking at other substances, so there's bismuth. I've got another couple of substances here, and this looks like a beautiful shiny metal. It's not that heavy, it's quite light, and this is not a metal. This is a crystal of silicon, which is being specially grown. It doesn't normally form like this, and this is grown like this, and it's been cut off here to try and make a silicon wafer, so we can make sort of computer chips with this. But we can see that this does glint and it's shiny like metals. And there's a famous saying that all that glisters is not gold. And here we've got something that's glistering really rather nicely, and it's not a metal at all. This one also looks fairly metallic, and this isn't a metal either. This is a piece of something rather boring. This is carbon in the form of graphite, and if I just write with it on here, we can see it leaves its sort of little crystals of, well, graphene, and we've got some graphene crystals basically down there. And if we look at this under the microscope, what we see is still a shiny crystal structure. And I'm going to risk life and limb now, because we're going to try and do that. Now, to get this to work better, what I'm going to do is the same thing, but I'm going to put it onto a small piece of paper. So I'm just going to cut out a small piece of paper. This is microscope slide size, and I'm just going to take my piece of graphite, and I'm going to scribble on there. Let's now take that, and there was a better crystal of it, so I will desperately try and pick that up, and let's put that one under the microscope. I'll switch the camera on again. And let's look at this under the microscope. If we just try and focus, there. We've got the black stuff on there, and what we might be able to see is glinting at us some crystals. And if I can just push the piece of paper around a little bit, we might be able to see the crystal. Struggling here. I'm working a long distance away. There we are. Found it. And there's our crystal. Does look shiny, does look very metallic, but in fact it isn't. It's a non-metal. So we can easily get confused by metals and non-metals, that they both look rather shiny and silvery, but this one is certainly not. This one is carbon. So we've looked at some non-metals and metals, and they don't really look very different. We've got bismuth, a metal. There we are, a piece of copper. This is actually an alloy. We've got the bismuth, we've got the silicon, and we've got the carbon in the form of graphite, and they all look very similar. All of these are found normally, naturally, the metals, as not pure crystals like this. We can find gold like this. We can find copper like this. And had I thought about it, I could have got a crystal of copper out to show you from Cornwall, but I'm not worried about that at the moment. But most of them come looking like this. Now what I'm just going to do is I'm going to bring in a little light to make that look a little bit better. And this here is something called peacock ore. And the reason for having the little light here is so that when we move this, you might be able to see that it glistens slightly differently and looks different sort of colours. And it's got golds in it, it's got purples in it, it's got some really beautiful colours. This is peacock ore. And we can also see the bismuth and the copper there by comparison. This is an ore. The metal is contained in here in a different chemical form, and we've then got to try and extract this out. Looking at it under ordinary light, it doesn't look quite so good, although you might see some colour changes there. So there we've got an ore and a couple of metals that you can see. We can take these metals and we can work out some of the properties from these metals. And so what we've got to try and do is, in a question, to explain some of the properties of metals from what we've got. So let's have a look and see if we can do just that. What we've got is some interesting properties. We've got these positive metals. We've got surrounding them delocalized free electrons. Now these electrons are free to move, and this allows for conduction, basically of heat and electricity. So conduction of heat and electricity, because these little electrons can move around freely. So that's one important property. The metals form giant structures. Let's zoom in a little bit. So we've got these giant metallic structures, huge billions of atoms of metals joined together. These little forces on these atoms work in all directions. Therefore, we have a high melting point, and even when they're liquid, they're still held together strongly, so they've got a high boiling point. Now, this metal forms special little layers. Let's try and show you what I mean. So my metal forms little layers, and these layers can slide over one another, and this gives rise to an important property of metals being malleable. This means to be hammered, And there used to be quite a lot of people working in the sheet metal business, hammering, bending metal to all sorts of shapes to make the bodies of cars, of other things. Nowadays mainly done by machines. But this is the property of these atoms, like this, sliding over one another. So one will go one way and one can go the other. And we can get the metal very thin, and we can bend it to all sorts of shapes. Another thing we can do with the metal is pull it out, so we can draw the metal out, and this forms wires. And this is a property being called ductile. So this is being drawn out into wires. There's another property related to this, and it's being sonorous. It actually sounds, it actually dings. And this one is a very easy experiment to do, just to try and show. And I'm going to get my son just to get me the lid of a saucepan out. Or a metal, any piece of metal will do. He's going to bring me a cake tin. Here we are, a cake tin. And I wouldn't suggest that this is one of the most useful things to do, but if we take our cake tin, we can turn it into our instrument. And it simply rings, because all metals have this property of being sonorous, that they actually ring when you hit them. So we've got the properties then, malleable, ductile and sonorous. It basically, it dings when you hit it. We can make bells out of some metals because they are better at this than others. Most of our typical metals are the ones in the transition elements. These are the ones we think of as the main metals. If we look at our periodic table, I'm just grabbing mine very quickly. Here are our typical metals. We think of typical metals not like magnesium ribbon, which we can burn, not necessarily like aluminium for pots and pans, but we often think of the metals as iron, cobalt, nickel, copper, zinc, and maybe chromium and manganese, although we don't see those as much. Titanium becomes a more common metal nowadays. I find it on my watch strap because it's quite good. We've got, going down, copper, we've got silver, gold. We do have a few odd metals. We've got mercury, Hg, and in this here it's not as liquid mercury, but that is done as mercury oxide, which is why it's not the right colour. So we've got a whole variety of different metals, and we think of these transition metals as our typical metals. There are a few odd ones, like gallium, and this gallium, if I warm it up, it will melt very, very easily and has some interesting properties. Well, we might as well have a quick look at this. So let's go over to the lab and look at this. Now, could you pass me the burner, please, Paul? Now, what I'm going to do is I'm just going to heat this up very, very gently, and we're going to get a mat to go underneath. My son's looking at me because I don't necessarily plan all these things quite as well ahead as I should. Let's turn this on, and I'm just going to heat this up very gently. And it's not been heated up an awful lot. That was a really quick bit of heating, and hopefully you can see that it's already starting to melt. Now, I've got some of that liquid. I'm just going to heat it a little bit more. Probably enough to do what I want to do with it. And here you can see we have some liquid gallium. Now, liquid gallium feels remarkably different to water, and it's very hard to describe, of course, a feeling to someone. It's a little bit dirty here, so I've got basically some crap on there. This is gallium oxide, but you can see that we've got some rather interesting gallium here, and it's a liquid. It feels dry to the touch, which is not what you'd think it's going to be like. So it feels dry to the touch. It doesn't spread out like water. If I make a little hole, it makes this sort of different shape, because instead of sort of having a surface tension where we're sort of trying to spread out, this is trying to sort of hold itself together. It's a slightly different form of surface tension than we see in water, exhibited by water. So water's a very atypical liquid, whereas here gallium behaves much more like a regular liquid. And yeah, you can see some nice shiny bits of gallium here. So gallium, a metal, it feels dry to the touch. I'll try and use a clean finger this time. And we can see it's got some sort of, it's wanting to sort of freeze here, because it's about 30 centigrade it needs to be, and this is not hot, as you can probably gather because I'm putting my finger in there. But it is a liquid. It behaves just as a normal liquid. It'll run, it'll move. You can pour it, but it's just different, and it's an interesting metal that's safe to play around with, whereas the metal that people do talk about that you could play around with is mercury. And when I was a child, we did get some mercury out and we did play with it, and now that would be terribly frowned upon because mercury is dangerous. And perhaps some of the dangers that we knew when I was younger, we didn't perhaps know as much about mercury poisoning then as we do now. But mercury does form some nasty sort of chemicals, organic mercury compounds, and this is where we get the phrase "as mad as a hatter" comes from, because they used to use mercury to make their hats smooth when they were playing around with felt. I hope that's given you an idea about some metals, some metal properties, boiling points, malleable, ductile, sonorous. You've seen then a liquid metal, gallium, and we've seen what metal crystals can look like under the microscope. Next time we'll move on from looking at this to nanoparticles, and that's very hard for me to try and show you what nanoparticles look like because, well, they're so small. But we'll have a look at those, and then we'll move on from there to look at some chemical calculations. So I'll see you next week. Take care, stay safe, and if you like this, please remember to subscribe. Bye bye.